What if I told you that in just 1 second, you could travel farther than any human has ever gone? Beyond the stars, past galaxies, and into the unknown. What lies at the edge of the universe, and what happens when we finally reach it? Prepare to ignite your deepest sense of wonder, because this journey will redefine everything you thought possible about space, time, and humanity's place in the cosmos. Imagine this: you're standing at the threshold of the impossible, a cosmic voyager poised for an unprecedented journey. The universe stretches out before you, vast and enigmatic, a tapestry of stars, planets, and galaxies waiting to be discovered. But what if you had the power to travel at a speed that defies the very laws of physics as we currently understand them? Imagine traveling at 1 light-year per second. Yes, 1 light-year per second. To truly grasp the sheer, mind-bending magnitude of this, consider this: light, the fastest entity in the universe, takes an entire year to cover that distance. Now, envision yourself covering that same immense distance every single second. The mind boggles, struggling to reconcile such a concept with our terrestrial experiences. This isn't merely a journey, it's a profound transcendence of everything we know about time, space, and possibility. It's the ultimate expression of humanity's insatiable drive to explore, to push boundaries, and to comprehend the incomprehensible. What if I told you that, with this unimaginable speed, in mere seconds, you could leave Earth, pass through our solar system, and journey across the stars, visiting distant worlds and exploring the far reaches of the universe, places humanity has only dreamt of, whispered about in scientific papers, and depicted in the most ambitious science fiction. This journey begins here, on Earth, a small, blue dot in the vastness of the Milky Way. It is the starting point for what could be the most incredible exploration of all time, a testament to our species' relentless curiosity. This isn't just science fiction, this is a vision of what could be, and perhaps, a tantalizing glimpse into the future of interstellar travel, a future where the cosmos is truly within our grasp. Now, as your spacecraft accelerates with an instantaneous surge of power, within a fraction of a second, you're speeding past the familiar landmarks of our solar system. Jupiter, the gas giant with its stormy beauty and iconic Great Red Spot, disappears behind you, its swirling clouds and 4 Galilean moons, Io, Europa, Ganymede, and Callisto, now a distant, fading memory. Europa, with its subsurface ocean, a tantalizing prospect for extraterrestrial life, is left behind in the blink of an eye. The icy giants, Uranus and Neptune, are but fleeting smudges of blue and white, their vast, frigid atmospheres blurring into streaks as you pass. Uranus, with its unique axial tilt, and Neptune, with its supersonic winds, become mere points of light. You've crossed the Kuiper Belt, a vast ring of icy bodies and dwarf planets like Pluto, remnants from the chaotic birth of our solar system, each holding clues to our cosmic origins. By the time you take your first conscious breath, you've already crossed the boundary of the heliosphere, the protective magnetic bubble created by the sun's solar wind, shielding our system from the harsher realities of interstellar space. Beyond this boundary, you've entered the true, cold, and silent expanse of interstellar space, a realm where the sun's influence wanes, and the stars become individual points of light rather than a collective glow. This rapid departure from our home system is a profound moment, marking the true beginning of your interstellar voyage, a journey that would take conventional spacecraft tens of thousands of years. But this is only the beginning of your awe-inspiring journey. Within just 4 seconds of leaving the heliosphere, you've already reached the Alpha Centauri system, the closest star system to our own. Alpha Centauri isn't just one star, it's a magnificent trio: Alpha Centauri A yellow star remarkably similar to our Sun in size and temperature, Alpha Centauri B, its slightly dimmer orange companion, and Proxima Centauri, a faint red dwarf, the closest of the three, just over 4.3 light-years away. For centuries, Alpha Centauri has captivated astronomers and science fiction writers alike, not just for its proximity, but because of its immense potential. Could there be planets here? Indeed, Proxima Centauri b, a rocky exoplanet, has already been discovered within its star's habitable zone, sparking fervent speculation about the possibility of life. The idea of life outside our solar system becomes all the more real as you zoom past this distant star system, knowing that future interstellar probes, perhaps even carrying humanity's future, might one day reach here, driven by the same spirit of exploration that propels you now. And just 4 more seconds later, a total of 8 seconds into your journey, you find yourself at Sirius, the brightest star in the night sky. At just 8.6 light-years away, Sirius is not just a beacon of light but a complex binary star system. One part of it is Sirius A, a brilliant main-sequence star, radiating intense blue-white light. Its companion, Sirius B, is a dense white dwarf, a star that has exhausted its nuclear fuel and collapsed into an extraordinarily small and dense object. The mere mass of this white dwarf is so compact that a teaspoon of its material would weigh several tons on Earth, a testament to the extreme physics at play in stellar evolution. As you approach, the overwhelming brightness of Sirius A is a stark reminder of the sheer power of stellar furnaces, and you realize how close yet how far away you are from the common understanding of stars. Sirius, with its twin companions, shines fiercely, its light a testimony to the vast differences in how stars live and die, a cosmic dance of creation and collapse. But you can't stop here, the universe beckons with more wonders. At 40 seconds into your journey, you arrive at 55 Concrete E, a planet unlike any you've ever heard of, a true marvel of planetary geology. It orbits its parent star so closely that its surface is a molten inferno, with temperatures rising above 1,400 degrees Celsius, hot enough to melt rock. But it's not just the extreme heat that makes this planet so unique. Beneath its fiery, lava-covered surface, scientists believe there could be vast quantities of carbon, compressed into diamonds, rubies, and sapphires, forming layers that no other planet could imagine. The very concept of planetary geology is challenged here, as a world so close to its star bears a molten surface, yet contains materials of unimaginable value, materials that could only exist under the extreme pressures and temperatures found in deep space. It's a diamond planet, a jewel of the cosmos, showcasing the incredible diversity of exoplanets. And then, 10 minutes into your journey, you reach Kepler 22b. This distant exoplanet, discovered years ago by the Kepler Space Telescope, is in what is called the Goldilocks zone, the perfect distance from its parent star, where temperatures could allow liquid water to exist on its surface. It's tantalizing to think about the potential for life here, a world that might harbor conditions similar to early Earth. Is it an ocean world, with no land, just vast expanses of water teeming with unknown life forms? Or is it a super-Earth, a world larger than ours, with a thick, possibly unbreathable atmosphere, yet still holding the promise of unique ecosystems? Whatever its true nature, the potential for discovery here is staggering, a beacon of hope in the search for extraterrestrial life. The fact that you've arrived here in a matter of minutes, while even our best propulsion systems today would take millennia to reach it, underscores the incredible scale of this journey. In the blink of an eye, you've crossed space and time in ways we've only imagined, turning millennia into minutes. But the wonders don't stop there, the universe continues to unfold its grandeur. In just 14 minutes, you've arrived at the Eagle Nebula, a breathtaking stellar nursery, the very birthplace of stars. This region of space is home to some of the most stunning sights known to humanity, massive columns of gas and dust, stretching light years into space. These towering structures, famously dubbed the pillars of creation, are where new stars are born, sculpted by the powerful forces of stellar winds and radiation. The formation of these stars is a chaotic and beautiful process, as the force of gravity pulls vast clouds of gas and dust together, eventually igniting nuclear fusion and forming new solar systems. But the pillars themselves are not eternal. Nearby supernovae are sending shockwaves through the region, causing some areas to evaporate and disappear, a constant cycle of cosmic destruction and renewal. What you're witnessing now is a fleeting moment in the life of the universe, a testament to the constant cycle of birth, destruction, and rebirth that governs the cosmos. It's a profound reminder of the dynamic nature of the universe, where even the most majestic structures are transient. At 5 hours into your journey, you encounter the immense VY Canis Majoris, a red hypergiant star so massive that 130 million billion Earths could fit inside it. This star is not just large, it is on the verge of its end, a cosmic titan living out its final, spectacular act. Stars like this burn bright and fast, consuming their fuel at an astonishing rate, and their lives are short and violent compared to smaller stars like our Sun. VY Canis Majoris constantly sheds vast amounts of material into space, creating beautiful, glowing arcs of gas and dust that stretch out in every direction, forming a complex nebula around it. The sheer scale of this star is unfathomable, defying human comprehension, and as you watch it, you realize just how small and insignificant Earth truly is in the grand context of the universe. The mass of such a star defies comprehension, and yet, this vast, fiery sphere is nothing more than a moment in the grand, eternal life of the cosmos, destined to end in a spectacular supernova, enriching the universe with heavy elements. At one day into the journey, you reach the edge of the Milky Way galaxy, and for the first time, you see its complete, majestic spiral structure. Our home galaxy, a breathtaking cosmic island, contains around 400 billion stars, each one a burning ball of gas, its own solar system, and potentially, its own story of planets and life. As you stare into the galaxy's depths, observing its luminous spiral arms, its central bulge, and the dark lanes of dust, you realize that our galaxy is only one of billions in the observable universe. The Milky Way, beautiful and immense as it is just a tiny speck in the grand design of the universe, a single star system among countless others. And as you continue your journey, the vastness of space becomes ever more apparent, stretching out in an endless panorama of stars and galaxies. But the journey doesn't stop at the Milky Way, it's merely a stepping stone. After 29 days, you enter Andromeda, our nearest galactic neighbor, a magnificent spiral galaxy even larger than our own. Andromeda is destined to collide with the Milky Way in about 4 billion years, a cosmic ballet that will culminate in the merging of two colossal galaxies into a new supergalaxy that scientists have affectionately dubbed Milkdromeda. The thought of two galaxies colliding, their stars and systems reshaping the very fabric of space, is almost incomprehensible, yet it is a certainty. The immense energy involved, the destruction and recreation of stellar neighborhoods, is a spectacular cosmic dance that will reshape both galaxies, creating new nebulae and star formation regions. This is the beginning of a new chapter in the story of the universe, and you, in your spacecraft, are witnessing the early stages of this momentous, slow-motion event, a testament to the dynamic and ever-changing nature of the cosmos. After 115 days, you pass the local group, a collection of over 50 galaxies, including the Milky Way and Andromeda, each with its own unique history and complexity. The galaxies here range from ancient, irregular ones to newer, more vibrant spiral and elliptical formations, all gravitationally bound. And as you leave this intimate group, you enter the Virgo supercluster, a truly massive structure that contains about 5,000 galaxies. Here, galaxies are bound together by the gravitational pull of their mutual attraction, forming clusters that span vast distances, like cosmic cities in the void. The Virgo supercluster is but one of many such structures scattered throughout the universe, each one a testament to the fundamental forces of gravity that shape the cosmos on its grandest scales. But this is only a small fraction of what is to come. The universe holds even grander structures. In 16 years, you'll pass the boundary of Laniakea, a vast supercluster that includes both the Milky Way and Virgo. Laniakea, meaning immense heaven in Hawaiian, is one of the largest known structures in the universe, a cosmic continent stretching across hundreds of millions of light years, where galaxies flow like rivers towards a common gravitational attractor. As you leave its gravitational influence, you enter the deep cosmos, an uncharted region where the mysteries of the universe are waiting to be uncovered, where the fabric of spacetime itself seems to stretch into infinity. A century into your journey, you come face to face with Ton 618, the largest known black hole in the universe. With a staggering mass of 66 billion suns, this supermassive black hole is a cosmic monster, a gravitational behemoth pulling everything around it into its inescapable event horizon. The immense gravitational forces at work here create a quasar, a bright, energetic beacon of light created as gas and dust spiral into the black hole at incredible speeds, heating up to millions of degrees and emitting powerful radiation. The sheer power of this object is staggering, a testament to the extreme physics of the universe, and as you observe it, you realize how small and insignificant everything else seems in comparison. It is a true singularity, a point where the laws of physics break down, and the very fabric of spacetime is warped beyond recognition. Your journey continues, and after 320 years, you pass the Great Wall, a structure so vast that it spans 10% of the observable universe. This is not a physical wall in the conventional sense, but a cosmic structure, a vast filament of galaxies, galaxy clusters, and superclusters that are bound together by the forces of gravity, forming an immense network. It is a profound reminder of the vastness of the universe and the incredible scale of the forces at play, a cosmic web that defines the large-scale structure of the cosmos. It is a testament to the early universe's quantum fluctuations that eventually grew into these colossal structures. This journey, though hypothetical, ignites the very essence of what it means to be human, to explore, to question, and to dream of what lies beyond. Which of the following statements do you find more compelling after this journey? A. The universe is so vast that it's impossible for humanity to ever fully understand its true scale and mysteries. B. The universe is vast, but it holds answers that humanity, through relentless exploration and scientific endeavor, can eventually uncover. Comment your answer in the comments below to let us know your thoughts, and don't forget to subscribe to our channel to stay updated with more mind-blowing journeys through the cosmos. Your support motivates us to create even more amazing content for you, fueling our shared passion for space exploration. If you found this journey inspiring, if your spirit of exploration has been ignited, don't forget to subscribe to our channel and hit that notification bell. Your support drives us to create even more thought-provoking and exciting content, bringing the wonders of the cosmos directly to you. Together, let's continue to explore the infinite possibilities that lie ahead, pushing the boundaries of what we know and inspiring the next generation of cosmic voyagers.